Hi, my name is Denis Mospanov, and I will be presenting my full-stack bad bag capstone project across the next 3 videos. This is part 1, a presentation of the app's front-end architecture, authentication, and an app diagram. So here's the diagram, breaking down the front end, middle tier, and back end. Starting with the front end, it is the client side of the application that runs the user's browser. It includes the HTML, CSS, and JavaScript code responsible for rendering the user interface and handling user interactions. Then you have the middle tier, acting as a bridge between the front end and the back end. It includes components such as API gateways, authentication services, and routing. Finally, we have the back end, which is the server side of the app that handles the business logic and data processing. It is responsible for handling the API endpoints for creating user accounts, retrieving user data, updating balances, deleting accounts, and providing user data for authentication. Moving on, let's look over the front-end architecture. Using the deposit page of the app as an example. Navigating to deposit on the app, we see a yellow card with a deposit title, 2 input fields for user email and deposit amount, followed by a deposit button. To best illustrate the front-end architecture, I will individually go over the routing, UI, state management, user input handling, and back-end communication. To reach the deposit page, the front end relies on routing. A key part to routing is the navigation bar that we see here taking us to all the different components of the app. Taking a look at the navbar.js code, we see the href attributes in each A tag, specifying the deposit, withdraw, and all other components in my public directory. These href values could be URLs as well. Now let's take a look at the code for the deposit form to understand the UI aspect of the architecture. We'll navigate to the public directory of the app and hop into deposit.js. The UI aspect of the architecture is handled in the return statement, where we see the BR tags that apply line breaks and button tags to render a button which handles the on-click event of submitting the form. To handle user inputs, input tags are used to create input fields for email and amount. The on-change event handlers are attached to the input fields, which trigger the setEmail and setAmount state variables. State is managed with the react.useState hook to define and manage those state variables I just mentioned. Now, this form would be useless if it didn't communicate with database to update balances and validate the user. For the front end to communicate with the back end, the handle function is called when the deposit button is clicked to perform several tasks, such as checking if the entered amount is a positive number using the isPositiveNumber helper function. If the number is negative, state is updated and the error message is displayed using the props.setError function. If the email does exist, a second GET request is made to the API to update the user's balance. I added some error handling for this updating process to easily catch bugs if the GET request fails and makes the user aware that their deposit didn't go through. All of this functionality works together to build a reliable front end. In terms of design decisions, I am passionate about implementing clear and concise error messaging for the user to best understand why the app may not be working for them. I hate inputting forms where I get a general error message that doesn't tell me exactly what's wrong with my inputs. This is why I implemented all of the error handling functionality that anticipates undesired user actions, like putting letters in a field expecting numbers, pointing out that the provided user email address doesn't exist in the database, and if there are errors with connecting to the database itself. 2 other UI elements I want to highlight are the updated balance after the deposit for the user to consult, and clearing the input fields of the form when an error is encountered due to an incorrectly input value, saving the user time, deleting the input themselves, or submitting the same faulty input again. While this is a bad bank because anyone can view the user credentials on the All Data page, there is still implemented authentication. Firstly, there is the authentication of the provided user email and password in the login.js component. When the user hits the login button, a GET request is made to the API database via special routes created to cross-reference input credentials with all credentials in the database. If the provided email address doesn't exist, the user will receive an error message warning them of this. If the password doesn't match a user's credentials in the database, a unique error message is provided as well. If all credentials match, the user is validated and allowed to log in. The second bit of authentication I have incorporated is into my database itself. While for demonstration purposes the application's database is open to any users with correct credentials, I can block access to specific users, which adds a layer of security to my application. While I spent loads of time trying to implement OAuth 2.0 into my application, it is unfortunately not natively compatible with MongoDB Atlas, which is the free database provider I am using. While there are third-party dependencies that claim to fix these compatibility issues, none of them resolved my issues. Since MongoDB Atlas provides their own integrated authentication functionality, I utilized that instead. So that wraps up part 1. Thanks for watching, and see you in part 2.